Um, we're live, and I'd like to introduce Rob Anstey, founder and CEO of GDI, and he will be talking about high performance 100% silicon anodes and giving us some technical updates.
Thanks. Really appreciate it. Thanks for having us back. I mean, one of the most exciting things since last time we talked is that we have made 4 amp hour standard pouch cells, because there was always a question about whether this technology would integrate into existing cell formats, because a lot of different silicons require making a cell differently, cycling a cell differently. So that was obviously a huge milestone for us. But let's get right into it. For those of you who are new to GDI, this is basically an update from our last presentation. Last time we were invited. What are the key things that we've accomplished and the main challenges with silicon? A lot of people have heard about silicon. It's a really exciting next generation anode technology, but it has issues. It expands, it contracts. It's hard to scale. It's hard to integrate into cells. You need pre-lithiation compression and new cell construction. Well, what's really exciting is we've really addressed these three critical areas with the progress over the past year. First off, as I showed you at the beginning, we have got into 21 layer 4 amp hour cells, and the expansion contraction does not damage the cell. It does not delaminate. It does not tear the foil. It does not deform the foil. So that's a huge achievement in the area of silicon, is getting 100% silicon that is going to go directly into normal cells without pre-lithiation or compression plates. The second thing is, none of that matters if you can't make it at scale. So we have signed an alliance agreement with AGC and Schlink in Germany to scale to industrial production. And we actually got some really exciting news at the beginning of the year that EIB, the European Investment Bank, is going to fund this program to get us to gigawatt scale. And that's the last but critical point. The economics matter, right? Yes, we're going after the premium market, the performance market, but it's critical to be able to have the low OPEX and the low CAPEX of the skyscraper market. And why am I bringing up the Shard in London? Because AGC coated that entire building with this plasma deposition method. So a lot of people go, oh, PV, CVD can't scale. Its economics suck. Yeah, normal lab R&D based, correct. But this is used to make skyscrapers. So no, this has very low CapEx, low OpEx, amazing economies of scale, and it's already been refined over decades in the glass business. So this will actually reach price parity with North American and European graphite at gigawatt scale, thanks to our partnership with AGC, one of the world's largest glass companies. So who is GDI? GDI is an anode maker. So we make 100% silicon anodes directly on foil. It's shipped in sheet to sheet or roll form. We have 13 issued patents, 40 pending. We've already raised over 20 million in investment to date, and actually we're well over 6 million in non-dilutive funding from ARL, DOE, DLA, NYSERDA, and others. We're the first company in the world to scale 100% silicon to megawatt capacity roll to roll in the picture I showed on the previous slide. And there's a great article in the Wall Street Journal about our partnership with the European Investment Bank to scale this up. But what's really exciting about this technology is EVs always get a bad rap about the carbon footprint of making the batteries. Well, one of the biggest issues is the carbon anode. The carbon anode has huge carbon emissions, both in the mining and processing and use of it. We replace all the carbon in the anode. It's 100% silicon. So we have already got carbon to do an analysis, and we lower the production emissions by 60, 80% cradle to gate. And then you're going to have a lower weight car, a car that can go further and charge faster. So that's another 6 to 7% in total emission reduction on a car level. So you're talking about significant emissions and pollution reduction in the process. So what's our first market? Our first market is defense. That's where we've got a lot of the funding. And what we've gone after is one of the most challenging applications there is. It's called the conformal wearable battery. This is in the bottom left. It's basically a wearable battery. So safety first. It has to have incredible high safety. It has to be light. It needs to be small. And you have to use the pouch cells like the one I showed at the beginning of the presentation. You can't put cylindrical in here or large prismatic, which means it's hard to get high energy in such a small cell. The great news is we've already achieved the energy, the cycle life, and the thermal penetration. So let me show a little bit more about why this is so hard. First off, you cannot have compression